Hello, thanks for joining us for this guide on developing modules within Vertex BD. In this short demo, we will go through the full design process of creating an individual module, starting with project creation before adding in walls, horizontal structures, openings and piping. We'll then frame fully panelize and frame the module, and then create the outputs including panel drawings and takeoffs. When Vertex is first opened, the Welcome window is displayed. This will allow you to open recently opened buildings. However, in this case, we will ensure a new building is selected and then click OK. This opens the New Building window. Our use will be building, and we can then give the building a 14-character ID, ensuring no spaces are used. Then, adding a more descriptive name in the field here. The Based On field allows us to select from either building templates or previously created buildings. We'll change this to a module template and keep the storage location as projects and then click OK. This then opens the project data card. Here we can enter details about the project. This is for information only, but it can be pulled through in the drawings. Once entered as needed, click OK. You will then see the drawing model pair window with the ground floor, walls, ceiling and floor pairs with their respective framing models. Now click on the ground floor walls icon here to open the drawing windows for the building. All commands can be found in the ribbon. However, to make Vertex more intuitive, we have a lot of common commands added to the contextual menu that can be accessed by right-clicking. As we will start with adding the walls, we will choose the Insert Wall command. First time this is selected, Vertex will bring up the Walls library. We can then choose an existing wall type and alter the layers if needed before clicking OK. We're then ready to add our walls. We'll start the project at the project origin and click to add our first wall point. With this selected, now right-click to bring up the contextual menu again. However, it will be different now with commands relevant to the commands we are in. We'll then go into the Constraints submenu. Note the keyboard shortcut keys that can also be used to speed up this action and choose Y-axis to snap the vertical direction. As we require a 4 meter by 8 meter model and are constrained in the vertical direction, we can start typing 4000 and the distance window will appear automatically. Once the correct figure is entered, hit enter on the keyboard. We can then repeat this horizontally by hitting U on the keyboard and entering 8000 and hitting enter. Again, I hit I to lock vertically and type 4000, then locking the x-axis again with U and return to the origin point, clicking when we see the yellow dot. The walls should automatically connect with a room labelled with the area. Vertex will keep us in the command to allow further walls to be added. As this will be an internal wall, we'll need to change it. This can be done from the right-click contextual menu. Select another wall command, which is the folder icon here. This will bring us back to the wall library where we can select a relevant internal wall, then press OK. We want to place the internal wall in the center of the long wall, hovering over around the yellow triangle in the center. This will appear denoting the center of the wall. We can then click this point to fix the wall there. Due to the wall placement, this will be slightly offset, so we can right-click and go to the contextual menu and then choose the placement wall middle icon. The wall will shift. We can then lock it in the Y-axis with the I key, with typing in 2000 and hitting enter to make the wall 2 meters long. Vertex keeps us in the command to add an adjoining wall. However, we can right-click now and click OK, or press V on the keyboard to confirm the wall placement. Again, we are still in the command to add an additional wall somewhere else. So now we need to right-click again and choose Exit or hit the Escape key to end the command. Now let's add some windows and a door to our module. First, select the wall you wish to add the opening to. Then, right-click to open the contextual menu, which will be different this time. Now select the Insert Window option to open the window library. We have a variety of window styles available to choose from. For this module, we will use the A-type 1200 by 1200 and click OK. This then fixes the window to our cursor parallel to the selected wall. We then click to place the window. Vertex keeps us parallel to the selected wall in case we require further windows on that wall. However, if we wanted to change to a different wall, we can right-click and choose and select the wall command. Now, click the wall you want to add the new opening to and place like we did previously. Once placed, we can exit out of the Insert Window command. Adding a door is the same process. First, selecting the wall to add the door to, right-clicking to bring up the contextual menu, and choosing Add Door this time. Select the appropriate door from the door library and click OK. Now place the door by clicking and then exit out of the command via your preferred method. Before we add our floors and ceilings, let's add some piping to the module. This is easier to do in the 3D model first. Switch into the 3D model by either pressing F2 or selecting the middle icon here. We can rotate the model into the 3D space by holding the Shift key on the keyboard and then the left mouse button whilst moving the mouse, while zooming in and out can be done using the mouse wheel. To get a better view of the back wall, we can hide the other elements. Select the back wall, right-click, and choose Hide Others. All of the geometry will now be hidden, and we will be able to add the piping more easily. First, let's select the piping option from the ribbon. Here, we can specify which types of piping we would like to add to our models. We will change the pipe size from the drop-down here to 32 to suit our wall frame size better. Now with that complete, we will zoom into the wall. To place it in the very center of the wall, right-click and choose Snap, then Middle. Now choose 2 points and the cursor will fix to the center. Hit L on the keyboard to lock the pipe in the vertical axis and drop down as far as is needed. Then click to place. To add a join, go back to the ribbon and select Add. Then choose the elbow angle needed. The cursor then fixes the pipe in line with the elbow. We can then draw this down to the underside of the wall and click to place, and then exit out of the command. We can then right-click and choose to restore hidden to bring back the rest of our module and switch back into the 2D plane by pressing F2. This is also a good point to save, which can be done with the save icon shown here. Now we can add our floor and our ceiling. First, bring up the modelling pairs by pressing F4 on the rightmost icon here and load the ground floor model deck pair. This will currently be blank. However, we are able to load a reference drawing of the ground floor walls we have already added. With the Modelling tab active in the ribbon, go to the Reference Drawing drop-down menu, select Quick Load Drawing Model Pair. This brings up the Drawing Model Pairs selection window, where the ground floor walls can be chosen to load in as a reference. To add the floor itself, right-click and select the Add Floor command. The floor library will open and an appropriate floor can be selected. Then press OK. We then need to determine the shape of the floor by selecting points. Due to this being rectangular, rather than selecting 4 corners, we can simply select 2 points diagonally, going from an external corner to an external corner. Ceilings are added in the same way as floors, but have their own modelling pair. We can switch to this by pressing F4 and choosing the ground floor ceiling model pair. Again, we go to the reference drawing and quickly load the floor as a reference drawing. To add the ceiling, go to the Model tab in the ribbon and select Ceiling. The Ceiling library will load, the ceiling type can then be selected, and then press OK. Again, draw 2 points from corner to corner diagonally to add in a rectangular ceiling. Switch back into the 3D using F2 and press H to hide a wall. If the ceiling needs adjusting, select it, then right-click and move it. And now select a reference point and then hit O to lock in vertically and move the ceiling to sit on top of the walls. Our architectural model is now complete. Again, this is a good time to save before we panelize and frame the walls. First, switch back to 2D using F2 and then press F4 to bring up our modeling pairs. Then switch back into the ground floor walls model pair. First, we need to split the walls into panels. To do this, select an external wall and then hold Ctrl on the keyboard and press A. This will select all external walls. Keep Ctrl selected, then select an internal wall. Now right-click and choose Generate Panels from the context menu. The Wall Panelizing Settings window will appear, where it's possible to select different settings to how the walls are automatically panelized. In this example, we will leave all these settings as they are and press OK. The walls will then be split and panel numbers will be added to the walls. To add the frame to these panels, select an external panel, then hold Ctrl on the keyboard and press A. This will select all external panels. Keep Ctrl selected, then select the internal panel. Now right-click and choose Generate Panel Parts from the contextual menu. All of the parts for the wall paneling will then be generated. We also need to add holes for the piping. In the ribbon, go to the Pipe drop-down menu and select Generate Utility Holes. Press All or None in the Selected Pipe Classes window and then click OK. Now select Wall Panels in the Object Types window and click OK. The utility holes will be added to the relevant panels. If needed, we can also add additional framing to these panels. For example, some integrated internal bracing. To do this, select the panel label of the panel for the brace to be added to, then right-click and choose Edit Parts. This opens up the panel in a separate window, making it much easier to edit. The sheathing can be turned off and on with the icon next to Sheets. To add the brace, bring up the contextual menu with the right-click and select the Framing Accessories option. Go into the Bracing folder and double-click the bracing type to be added. In this example, K-bracing will be added. Now select the panel and click OK to the bracing options. Then select 2 points diagonally, starting at the bottom corner of the bay the brace is to be added to, clicking near to the corner but not actually on the frame. The temporary model can then be closed. Next, we can frame our floors and our ceilings. Starting with the floor, press F4 to bring up the drawing model pairs and load the ground floor deck modeling pair. Select the floor, then right-click to bring up the contextual menu and choose Panel Break. The cursor will change, denoting the starting point of the breaks. Let's choose the midpoint of the internal wall, and red panel break lines will be added to the floor plan. Right-click and then exit out of the command. Our floor will then still be selected, so right-click again and select Generate Panels this time. Red panel labels will appear. To frame these, click and drag around them, or hold Ctrl and press A. Panel text will go green. Right-click and select OK, and then alter the panel parameters if necessary and press OK. The panel parts will then be generated and panel numbers added. Let's repeat that for our ceiling. Press F4 to bring up the drawing model pairs and load the ground floor ceiling modeling pair. Select the ceiling, then right-click to bring up the contextual menu and choose Panel Break. The cursor will change, denoting the start point of the breaks. Let's choose the midpoint of our internal wall, and red panel break lines will be added to the ceiling plan. Right click and then exit out of the command. Our ceilings will still be selected. Right click again and select Generate Panels this time. Red panel labels will appear. To frame these, click and drag around them, or hold Ctrl and press A. The panel text will go green. Right click and select OK. Alter the panel build parameters if necessary and press OK. The panel parts will be generated and the panel numbers added. Our framing is now complete. Let's look at the framing model first, switching to the framing model with the leftmost icon at the top of the window. Then switch to 3D with the middle icon. If the model looks OK, we can then proceed with the outputs beginning with the panel drawings. Go to the Output tab in the ribbon and select Panel Drawings. Select all of the panels by holding Shift, selecting the topmost panel, then the bottommost panel. Right-click and select Create. Choose the appropriate panel template for the flooring panels and click OK. Do the same for the ceiling panels and finally the wall panels. Once done drawing, status for all the drawings should be OK. Press the exit button once that's complete. A takeoff can then be generated by going to the Excel list in the Output tab and choosing the appropriate report type. Click OK and then press the All button to select the panels and then OK. Vertex will then collect all of the necessary components and open a report in Excel. Thanks for joining us for this video guide on how to make small modules within Vertex BD.